A pleasant day, everyone. By the way, we are going to continue with our discussion about chemical reactions, but in this way, we will be having our sample problems in the previous lecture that we have, it was only being specified on what is really a chemical reaction. We already know that chemical reaction has something to do when two compounds or an element or a compound combines together to form a product. Okay, that is a chemical reaction wherein there is a reactant and at the same time what is being produced is the product. And we already know that there are 5 types of chemical reaction, namely the combination, and it has a general formula of A plus B is equal to AB. Then we have the decomposition wherein it is AB. Once it is being added with heat, what will happen? It will be split into A plus B, and there is also a combustion, meaning a compound added with or applied with oxygen, it will always form into carbon dioxide and water. We have also double displacement method, wherein a compound and another compound combines together to form two new compound, and we have a single replacement method wherein a compound with an element combines to form another compound and another element. That is a chemical reaction. So what happened in the previous lecture is we didn't have yet the sample problem. So in this lecture, we are going to discuss each of those, those problem sets. Okay, so let us start. Of course, because we are dealing with chemical equation, this is very important in the calculation of a certain process, wherein it needs a balanced equation. But for this problem, this is just a kind of a review, wherein we are going to know how to convert a gram to mole, mole to atoms, or mole to molecule. So if we are going to convert gram to mole, all we have to do is we are going to use the formula weight or the molecular weight. So if it is mole to atoms or mole to molecules, all you have to do is we are going to use also the Avogadro's number. What is the Avogadro's number? That is 6.022 raised to the power of or times 10 to the power of 23, either atoms, particles, or molecules. So those are the things that you should remember in the conversion of gram to mole, mole to atoms, molecules. Okay, so here we are. This is chloral hydrate, which has a formula of C2H3Cl3O2. Actually, this is used as a sedative or hyponetic drugs. Okay, so in A, we are going to solve for the molar mass of chloral hydrate. B, we are going to get the number of moles if the given is 500 grams of chloral hydrate. Then letter C is what is the mass in grams. If you have 2.0 times 10 to the power of 22 moles of chlorohydrate. And finally, what is the number of chlorine atoms present in 5 grams of chlorohydrate? So as you can see here, we solved it by this manner. Okay, so letter A is getting the molar mass of chlorohydrate, which has a formula of 2 atoms of carbon, that is 2 times 12. Where did we get that 12? That is in the periodic table. We are going to see the molar, periodic table here. The atomic weight of carbon, which is 12. Okay, then how many atoms of hydrogen? 3. Then it is 1 gram per mole, or AMU, atomic mass unit. Chlorine, we have 3 times 35. Then oxygen, 2 atoms times 16. So sum it up, that is 167 atomic mass unit, or 167 gram per mole. In letter B, we are going to make use of this molar mass that we have in getting the moles of chloral hydrate. In what way? The given is 500 grams of chloral hydrate. Multiply this, as I have said, if it is gram to mole, what you're going to do is you are going to reverse your molecular weight. The mole should be top and the molecular weight should be down to cancel the unit. Okay, that is mole over 167 grams of chlorohydrate. So cancel. What we have now is the moles of chlorohydrate, which is 2.99 moles. Then in letter C, we are going to solve for the mass of chlorohydrate, wherein the given is 2.0 times 10 to the power of 22 moles of chlorohydrate. And again, this is mole to gram. Therefore, we are going to multiply this with the molecular weight of chlorohydrate, which is 167 grams over moles. So cancel the mole. We have now equivalent. The unit here is grams. Now the mass of chlorohydrate is 3.34 times 10 to the power of 24 grams of chlorohydrate. And in letter D, we are going to get the number of atoms of chlorine, wherein the given is 5 grams of chlorohydrate. Multiply this with the molecular weight, but it should be in the reverse. So we can cancel the grams. Then convert again, using the, what I call this, in order to come up with the molecules of chlorohydrate. We use the Avogadro's number that in 1 mole of chlorohydrate, that is equivalent to 6.022 times 10 to the power of 23 molecules of chlorohydrate. Okay, and finally, as we can see here, how many atoms are there in the 1 molecule of, in 1 mole of chloral hydrate? There are 3, chlorine. So 3 atoms of chlorine in 1 mole of chloral hydrate. Cancel the mole there. And now we have 5.4 times 10 to the power of 22 atoms of chlorine. Okay, so that is for sample problem 4. Let us now move on. As I have said, this is an application wherein no problem because the balance equation will be given. So in calculating this, be sure that the equation, the first thing that you should look into is if and when the equation is balanced. Okay, so this is ferrous sulfide added with oxygen to form ferric oxide and sulfur dioxide. Okay, so first thing that we should know is it balanced? Take a look. How many atoms of iron in the reactant? That's 4. Then sulfur is 8. Then for oxygen, we have 22. How about here? Oh, it's balanced because we have iron 4, oxygen is 6 plus 16, it's 24. Then 8 for your sulfur. So the equation is balanced. So we could proceed now to our solution. So what is needed here? What is the mass of sulfur dioxide produced? And what is given is 3.8 grams of ferric sulfide, ferrous sulfide kani. So in letter B, what is the mass of ferric sulfide needed to form 4 grams of that is ferric oxide. Okay, what is very important is your basis will always be your equation. In converting to mole to mole, mole to mole, the mole of the given and the mole of the unknown, the required. So here it is. This is our equation. That is 4 moles of 4 molecules or 4 moles of ferrous sulfide, then 11 molecules or 11 moles of oxygen, 2 moles of ferric oxide, and 8 moles of sulfur dioxide. First is let us get the mass of sulfur dioxide with the given 3.8 grams of ferric ferrous sulfide. So first thing that you should do is convert this so that we can move on to the mole of sulfur dioxide. Let us convert this first into mole, ang atong ferrous sulfide. So how are we going to convert that? Of course, we'll be using the molecular weight. What's the molecular weight of ferrous sulfide? That is 120 grams. As I have said, if it is mole, you should reverse it. The molecular weight should be reversed. The mole of ferrous sulfide is top and the 120 grams of ferrous sulfide down. So cancel the grams. So ang nabilin taas is mole of ferrous sulfide. But we don't need the moles of ferrous sulfide. What we need is the moles of sulfur dioxide. So in this way, if it is now mole to mole relationship, meaning the mole of the given and the mole of the required. Okay, in this way, we can use now the balance equation. So we have here 8 moles of sulfur dioxide and 4 moles of ferrous sulfide. So cancel now the moles of ferrous sulfide. What is left here is the moles of sulfur dioxide. But what we need is the grams of sulfur dioxide. And this way, we need to know the molecular weight of sulfur dioxide. The molecular weight of sulfur dioxide is 64 grams per mole. Therefore, the 64 grams of sulfur dioxide over mole of sulfur dioxide, cancel the mole. And what we have now is a remaining unit is already the grams of sulfur dioxide. Therefore, that is 4 point, multiply, use the mathematical part. That is 3.8 divided by 120 or 3.8 multiplied by 8 multiplied by 64 over 120 times 4. But what I'm using is because I don't have the battery of my scientific calculator is flat now. So what I always did is I have it one at a time. That is 3.8 divided by 120 equal to multiply by this is divide man mo siya 4, no? That is divide 8 divided by 4 is 2. So multiply by 2 multiplied by 64 equals to 4.05 grams of sulfur dioxide. So we already solved now our mass of sulfur dioxide with a given 3.8 grams of ferrous sulfide. Then what is in letter B? No, still we will be using the balance equation wherein what is given is 4.1 grams of ferric oxide, and what is needed is the mass of ferrous sulfide. Okay, let us have it. That is 4.1 grams of ferric oxide. Then, as I have said, it should be converted into mole before kamuadto sa unknown nga. Okay, which is unknown nga ferrous sulfide. Okay, so that is you get now the molecular weight of ferric oxide, which is 160. But let us reverse to come up with a mole. Therefore, cancel ang grams. Ang nabilin is mole. No? Then, this is now the time that we can use now solve for our unknown, which is ferrous sulfide, using the balance equation. There are 4 moles of ferrous sulfide, no, which is needed to produce 2 moles of ferric oxide. So cancel ang moles of ferric oxide. But what is needed is not yet moles of ferrous sulfide. What is needed is the grams. And of course, I have said if it is mole to gram, get now the molecular weight of ferrous sulfide, which is 120. So cancel the mole now of ferrous sulfide, cancel the mole of ferric oxide. Finally, we have use now the mathematical side, that is 4.1 times 4 times 120 divided by 160 times 2, you have 6.15 grams of ferrous sulfide. So this is how you're going to calculate, no? That is based on the balance equation. Okay. Let's have another example. So this is, over the years, the thermite reaction has been used for welding railroads rails in incendiary bombs and to ignite solid fuel rocket motor. So this is the reaction of the solid fuel rocket motors. That is ferric oxide plus aluminum, is equal to, this kind of reaction is single displacement. So wherein your aluminum will replace your iron because your aluminum is more reactive than iron to form into aluminum oxide. Okay, be sure to balance the equation. Okay, the equation now is balanced, and I know you already know how to write a chemical formula, which was discussed on the first part of our lesson. So what is needed here is, what is the mass of iron? Kani mass of iron, what masses of iron oxide? Kani iron oxide kani must be used to produce and aluminum kani reactant mo iron oxide and aluminum, wherein the given is 15 grams of iron. Okay, here is the solution. As I have said, what is very important, of course, is your balance equation. So let us now have the mass of ferric oxide. The first given is 15 grams of iron, multiplied by what is the molecular weight of iron, that's 56, but you should reverse it. That is mole of iron, or 56 grams, cancel the grams. Okay, we have now the mole. But what is needed here is not the iron. What is needed here is the ferric oxide. Therefore, you can make use of the balance equation for the mole-to-mole ratio, wherein we have 1 mole of ferric oxide is needed to produce 2 moles of iron. So cancel the iron. We have now the mole of ferric oxide, but it should be in grams of ferric oxide. Get now the molecular weight of ferric oxide, that is 160 grams of iron. So cancel now the mole. What remains kanina lang, that is grams of iron. So use the mathematical side, that is 15 times 160 divided by 56 multiplied by 2, you have 21.43. That is ferric oxide. How about the mass of aluminum? The mass of aluminum with the given same gapon 15 grams, that is 15 grams of iron. Then convert that into mole of iron with multiplying with the molecular weight of iron, that is 56. That is mole over 56 grams. Cancel the mole grams. What remains is the mole. Kay mole naman pwede na ta makakuha sa mole of aluminum using the equation. You have here 2 moles of aluminum is needed in order to produce 2 moles of iron. So cancel the moles of iron. What remains is the mole of aluminum. But what we need is the grams of aluminum. So multiply this with the molecular weight of aluminum, which is 27 grams over the mole. So cancel the mole. What remains is now the grams of aluminum, which is 7.23 grams of aluminum. So that is sample problem 5, and this is solving a problem based on the balance equation. And now we have the reaction yield. As I have said in our previous lesson, reaction yield is equivalent to, the percentage yield is equal to what? That is the actual yield over the theoretical yield multiplied by 100. In most cases, the actual yield is less compared with the theoretical yield. So here we have the equation of 10 gram sample of potassium bromide. This is potassium bromide is treated with perchloric acid. This is perchloric acid solution. The reaction mixture is cooled and solid. This is now your product, which is potassium chlorate, in a form of solid, and hydrogen bromide. So the product weight, of course, your product is 1. Okay. Okay, so as you can see here, that's the problem. The connection will always magkawala, no? Anong but kahinay disconnection karon. So what we have here, the actual yield, this one, the product weight 8.8 grams. So this is now the actual yield, no? Actually, the theoretical yield is we need to solve it. So how are we going to solve for the theoretical yield? Okay, so here is the sample problem. That is potassium bromide. And here, no, we have the perchloric acid, no, to form potassium chlorate and hydrogen bromide. So the given in the problem, which is 8.8 grams, that is now the actual yield. What is needed is we need to calculate for the theoretical yield of potassium chlorate, no, with a given of 10 grams of potassium bromide. So next thing is, let us convert this, no, 10 grams into mole. So by having the molecular weight of potassium bromide, which is 119. So reverse it, that is mole over 119 grams of potassium bromide. Cancel the potassium bromide, we have now the mole of potassium bromide. In this case, we could already convert now what we need, which is the potassium chlorate. Now, from the balance equation, we need 1 mole of potassium chlorate to form 1 mole of potassium bromide. So cancel mole of potassium bromide. And finally, what is needed is the mass of perchlorate, the potassium chlorate. So get now the molecular mass of potassium chlorate, which is 139 grams of potassium chlorate over the mole. So cancel the mole of potassium chlorate. Then use now your mathematics by multiplying 10 times 139 divided by 119, we have 11.68 grams of potassium chlorate. This is now our theoretical yield. Therefore, in the calculation of the percentage yield, we have it, what's that? That is the actual, which is given 8.8. Then the one that we solve, which is the theoretical yield, which is 11.68. Now divide it times 100. That is 75.34%. This is now the percentage yield. So this is how you're going to get the percentage yield of your given compound. So another example. So we have here the adipic acid. Let me see. Problem 8. Okay. We have the adipic acid with a formula of H2C6H8O4 used to produce nylon. Nylon is made commercially by reaction of cyclohexane. Cyclohexane is C6H12 and oxygen. So this is the reaction. This equation is balanced, wherein that is the cyclohexane added with oxygen, you will form adipic acid, which is this formula, and water. So letter A, assume that you carry out the reaction with 25 grams of cyclohexane, 25 grams of this. And that cyclohexane is the limiting reactant. What is the theoretical yield of adipic? So therefore, let us solve it here. Use the 25 grams of cyclohexane for solving the theoretical yield of adipic acid. That is 25 grams of cyclohexene, you get the molecular weight of cyclohexene, which is 84. It should be reversed to come up with the mole here. Therefore, cancel now your grams. So let us move on. Laghinay ang internet connection. So we have now, we have now the mole of, the given here is 25 grams to get the theoretical yield of adipic acid. Let us use the 25 grams of cyclohexene, then convert that into grams to mole using the molecular weight of adipic acid, which is 84. Then it's now, we can convert it to mole ratio from cyclohexene to adipic acid using our balance equation. We have 2 moles of cyclohexene here and 1 mole of adipic acid. So cancel now your mole of adipic acid. What we have here is mole, but what is needed is grams of adipic acid. Using the molecular weight, we have 146 grams of adipic acid. Cancel the mole. What we have is 21.73 grams of adipic acid. Actually, this is the theoretical, and the given is, let me see. The given here is 33.5 grams. Is the actual yield. Okay. Therefore, what we have here is actual over theoretical, diba? Because what we had solved is the theoretical. That is 33.5 divided by 21.73. It has 154.16. So, sobra iyang percentage yield. But in most cases, it's the other way around. Panagsarag yun na nga musobra. In most cases, the percentage yield is lesser than 100%. Okay, so that's problem A. Then, let us look into the reaction. We have 2 reactants, diba? Dua kabuk reactant. For instance, this portion here, that is nitrogen and hydrogen. Diatomic nitrogen and diatomic hydrogen to produce ammonia. Okay, so in this case, this is our reactant. So in the reactant, there is limiting, meaning mas gamay, na apoy excess, mas naku. So the limiting reactant and excess reactant, we can calculate it if and when there is 2 given values. For instance, this one, the most important commercial process in converting nitrogen from air into nitrogen-containing compounds is based on the reaction of nitrogen, diatomic nitrogen, and diatomic hydrogen to form ammonia. So in this one. So how many moles can be formed in 3 moles? As I said, wag yun ang given in getting the product. That is given here is 3 moles of nitrogen and 6 moles of hydrogen. So what we are going to do is we are going to solve this. We are going to solve the mass or the mole of ammonia using these 2 reactant. Okay, here. So this is it. So let us now solve for the moles of ammonia, but we will be using the 2 given. The first given is 3 moles of nitrogen. Okay, so that is 3 moles of nitrogen times by, multiply it with the balance equation. We have it is needed 2 moles of ammonia to react. 2 moles to produce from the reaction of 1 mole of nitrogen. So cancel the nitrogen, that is 3 times 6 is 6 moles of ammonia. If we will be using the reactant
reactant, which is nitrogen. The second one is, let us now use the reactant, which is 6 moles of hydrogen. Therefore, the second is 6 moles of hydrogen multiplied by, use again the equation. There are 2 moles of ammonia produced from the reaction of 3 moles of hydrogen. So cancel, cancel. That is 6 times 2, 12. 12 divided by 3 is 4. No? So that is, which is greater? Of course, greater, ang mas dako is when we use the reagent, the reactant, which is nitrogen. It will produce 6 moles. Asa may gamay, when we use hydrogen as a reactant, it will produce 4 moles. So, therefore, hydrogen, kay gamay man siya, is known as the limiting reactant, or in short, LR, while mas dako man ni siya using this nitrogen, therefore, N2 is the excess reactant, or ER. We are already following. Okay. So another problem for limiting reactant, we have here in the hydrolysis of hydrogen plus oxygen to form water. No? This is used to produce electricity in hydrogen fuel cell. Suppose a fuel cell contains, ang una, 150 grams of hydrogen, diatomic hydrogen. The other one is 1,500 grams of O2. So how many grams of water can be formed? Kung nga pag yun siya, kinsay limiting o kinsay excess reactant. Here. So we have this. Let us find now the mass of hydrogen, of water. But we have 2 given. The first one is using 150 grams of hydrogen. So 150 grams of hydrogen multiplied by, use the molecular weight, that is mole of hydrogen over 2, that's 1 times 2. So 2 grams of hydrogen cancel the hydrogen. And using the balance equation, we have 2 moles of water is needed, is produced, which is reacted with 2 moles of hydrogen. So cancel the moles. No? And finally, because it is in grams, therefore multiply it with the molecular weight of water, that's 18 grams of water. So cancel the mole there. Then use now the mathematics. No? That is 150 for your computation. 150 multiplied by 2 multiplied by 18 divided by 4. It is 1,350 grams of water. Now, let us still solve for the mass of water, but now we are going to use the oxygen, which is 1,500 grams of oxygen. Multiplied by, use the molecular weight of oxygen, it's the atomic 10 times 2 is 32. Cancel the grams. Then use the mole ratio, which is 2 moles of water is needed to react with 1 mole of oxygen. So cancel here the moles of oxygen. And finally, multiply it with 18 grams of water. And you have 1,500 multiplied by 2 multiplied by 18 divided by 32 is 1,687.5, which is greater, of course. This one is greater, therefore the excess reactant is using oxygen, while the limiting reactant is using hydrogen. So therefore, hydrogen is the limiting reactant, kay mas gamay siya kani using this one. Then oxygen is the excess reactant, kay mas dako siya. Okay, so that is sample problem 8. Another problem, okay, here. This is a fuel mixture of bracketary consisted 2 fluids. That is the hydrazine, monohydrazine, and the dinitrogen tetroxide. Na? Once you ignite this will produce a nitrogen gas, carrying nitrogen gas, of a water vapor. What is being asked? Okay, how many grams of nitrogen gas can we to form into, di ba, duha ganing given sa reactant, mabalaan nimo, which is excess, which is limiting. So that is 1.0 times 10 to the power of 2 grams of dinitrogen tetraoxide. The other one is 2 times 10 to the power of 2 grams of dinitrogen. Mani. Dinitrogen tetraoxide. This is tetra or hydrazine. This is dinitrogen tetrahydride or hydrazine. Then in the B, how much is the excess remaining unreacted? Okay. So let us solve it here. No? The mass of the nitrogen gas. Okay. No? Using first our dinitrogen or the hydrazine. Hydrazine. So 1 times 10 to the power of 2 grams of hydrazine multiplied by its molecular weight, but we have it reversed. That is 32 grams. So cancel the grams. Then use now the molar ratio. There are 3 moles of N2 produced, okay, which is reacted with 2 moles of hydrazine. Okay. And get the molecular weight of dinitrogen, that is the diatomic nitrogen, that is 28, 14 times 2. Then cancel the mole. What remains is the grams of nitrogen. So multiply this, that one. You come up with 131.25 grams of nitrogen. Next is using the other reactant, which is the dinitrogen tetraoxide. Okay, that is 2 times 10 to the power 4 grams times moles of dinitrogen tetraoxide over 94. Okay, then use now the mole ratio. That is 3 moles of nitrogen and 1 mole of dinitrogen tetraoxide. Multiply by the molecular weight of nitrogen. We have 182.61. So which is the excess reactant and which is the limiting reactant? Of course, kanimoy gamay. So using the dinitrogen or hydrazine, your hydrazine is the limiting reactant, while the dinitrogen tetraoxide is your excess. So how much is the excess? Excess in letter B, excess reactant that remains unreacted is the given 186 as 186. Oh, that's the one. Let's go back. No, that is it. Oh, it's not 186, but 182. Sayop ni ha? 182.61 minus 131. Pila man ni siya? No? So it's at 51, possibly mga 49. Okay, 49.36 grams. Sayop ni ha? This should be 182, not 186. Okay? So that is in solving the limiting and the excess reactant. The next one is, how are we going to calculate empirical formula? We had already discussed this empirical formula. Empirical formula is not the true formula. This is just the simplest formula, wherein the true formula is the molecular formula. So how are we going to calculate it? Okay, so in case what is given is in terms of percentage. So as you can see here, there are 3 components of your compound. That is the potassium, 24.75%, the manganese, 34.77%, we have the oxygen, which is 40.51%. The step 1 is, of course, we will make a base. If we are going to sum this percentage there, this one, this will be 100%. So let us assume that we have 100 grams of a sample. That's our basis. So you can already equate the percentage sign into grams. The second one is you have already grams. So convert that into mole using the molecular weight. And finally, you divide it with the lowest value, and that will now serve as your number of atoms of each of the elements. Let us keep the ball rolling by applying this. Sample here. So we have a basis of 100 grams of a sample. So we have the mass of potassium. Di ba ingon ko sa inyo, kung sa ito yung percentage, largo na mo siya pwede himuon grams. So it's 24.75 grams. The grams of manganese is 34.50 grams. The grams of oxygen is 40.51. The next thing is, that's letter A. Letter B is you're going to convert that gram into mole using the molecular weight. So the mole of potassium, that is 24.75, multiplied by reverse the molecular weight. The molecular weight of potassium is 39 grams, so it is 0.63. The molecular weight, the mole of manganese is 34.77 multiplied by the reverse of its molecular weight, which is 55, it's 0.63. Then the moles of oxygen is 40.51 grams multiplied by its molecular weight, which is 16 grams per mole, it's 2.53. The next thing, letter C, is the number of atoms. Look into this as a smallest, lowest. Of course, it's 0.63. I-divide mo na siya sa tanan. Therefore, the number of atoms of potassium is 0.63, that one, and the lowest is 0.63. Therefore, it has one atom. Then, number of atoms of manganese is still the same, 0.63 divided by 0.63 is equal to 1. And finally, for the number of atoms of oxygen is 2.53 divided by 0.63 is 4. Therefore, EF here is the empirical formula is potassium pila 1. Ayun na butangig 1 ha. 1 atom. Manganese pila 1. Ayun na butangi. Then your oxygen is 4. Therefore, the empirical formula of your compound is KMnO4. Okay, that is in the calculation of the empirical formula. How about in the molecular formula? Here. So, this is another example. No? Ethylene glycol used in anti-mobile. Okay. Antifreeze ka ng dili siya mo, no? The antifreeze there is the one that is needed in order to minimize the knocking in your automobile. That is, it needs an antifreeze. Okay. And antifreeze is in a form of ethylene glycol. Okay. What is the formula of ethylene glycol? That is CHO. Okay. With its, these are now the given, the percentage. No? But its true molar mass is 62.1. Okay. So what is needed in letter A? What's the empirical formula of ethylene glycol? We will use the 3 ways. The first way is have a basis of 100. The second one is convert that into grams. Then letter B is convert that into mole. No? How? That is by multiplying it with the molecular weight. And finally, divide it with the lowest number, which will serve as your number of atoms. Okay. And the molecular weight later na. Yan na, para matudloan saon. So here it is. We medyo hanap-hanap siya gamay. Na? So that is the grams of carbon, 38.7 grams. Katong percentage, largo na ito mo siya gram because we have a basis. I forgot to place here the basis of 100 grams of sample. Then the grams of hydrogen, 9.78 grams, 9.7 grams. I mean, grams of oxygen is 51.61 grams. Okay. Let us have the moles of carbon. Have this given, 38.78. Divide it with the molecular weight, which is 12. So it's 3.23. Then the moles of hydrogen, 9.78. Then, of course, the molecular weight of hydrogen is still 1. Okay, so that's 9.78. The moles of oxygen, that is 51.6. Then divide it with the molecular weight of 16. So we have 3.23. Which is the lowest? The lowest is 3.23. Therefore, divide this for the number of atoms. The number of atoms of carbon is 3.83. Divided by 3.23 is 1 atom. Number of hydrogen, 9.78 divided by 3.83 is 3 atoms. Number of atoms of oxygen, 3.23 divided by 3.83 is 1. Therefore, here the empirical formula, copy.
Okay, so let us go on. Pisagsigig loading. Therefore, that we have the empirical formula. How many atoms of carbon? 1. How many atoms of hydrogen? 3. How many atoms of oxygen? 1. Therefore, empirical formula here is CH3O. Okay? But how are we going to get the molecular formula? Okay, so first thing is you get the molecular weight of the empirical formula, that is CH3O, that is 12, then 3 and 16, 31 grams per mole. Then the given, which is 62.1 divided 31, meaning there are 2 atoms in each of the element. The molecular formula is the empirical formula is CH3O. Multiply that with the subscript 2. Therefore, that is 2 times 1 for carbon, we have CH2. 2 times 3 for hydrogen, we have H6. Then 2 times 1 for oxygen, we have O2. Therefore, the molecular formula of this compound is C2H6O2. So that is how to calculate for the empirical and molecular formula. I hope that you understand it, and thank you. Good luck, everyone.